Welcome back. This part will be a bit longer as we delve into the tracking process, exploring nearly all the settings involved. Get ready for an in-depth journey as we thoroughly cover the intricacies of tracking. Start by opening Blender and navigating to the Motion Tracking tab. Since we have started a new Blender project, ensure once again that you have the standard View Transform option enabled in the Color Management tab. This will help maintain the accurate color representation in your project. Set Scene Frames adjusts the frames so it matches the footage. Prefetch loads the footage into the memory so you can preview it real-time, and Reload removes the prefetch. Add adds a tracking marker with the specified options applied below. Delete removes a selected tracker from the scene. And Detect Features automatically detects features for the frames based of high contrast points with low motion blur. These settings determine the behavior of the tracking points. The pattern size controls the area in which the tracker searches for patterns, while the search size determines the size of the area used to look for the specified pattern. The motion model setting influences how the trackers behave based on the perspective changes throughout the shot. Match determines how the tracker attempts to find the pattern between frames. Prepass calculates information about the camera motion and scene geometry before performing tracking, resulting in improved accuracy. Normalize normalizes the light intensity values, enhancing tracking capabilities in exposed parts of the footage. In the Motion Model panel, there are 6 different motion models. The most commonly used is the Perspective model, which tracks markers with perspective deformation and homography. It's ideal for tracking free camera movements and planar surfaces. The Affine Motion model is used to track points with shearing deformation and enables the tracker to approximate perspective changes. The remaining tracking models have specific limitations, with location, rotation, and scale trackers encompassing all changes, while the others focus on specific parts of these changes. In the Match preset, there are 2 options to choose from. The first one is Keyframe, which tracks patterns from one keyframe to the next. The other one is Previous Frame, which tracks patterns from the current frame to the next frame. In summary, Keyframe allows you to manually set the starting position of the tracker, while Previous Frame uses the tracker's position from the previous frame as the reference for motion tracking in the current frame. I recommend using Previous Frame in most projects. The RGB options determine which color channels will be used in the tracking process. When all the boxes are highlighted, it means that all channels will be used for tracking the footage. The Copy from Active Track button copies the settings from the selected tracking point to become the default setting for the next added tracking points. In the Tracking Settings Extra panel, you will find 4 more options: Weight, Correlation, Margin, and Use Mask. The weight slider determines how much influence the added marker should have. Adjusting this can be beneficial if a tracker is moving closer to the edge of the screen, allowing for smoother movements by transitioning the weight slider from 100% to 0%. This can lead to a better solve value. The correlation slider describes how certain the tracker needs to be between frames to be considered a successful track. Higher values provide more precise trackers, but with shorter lifespans. The margin slider determines how close the tracker can be to the border until it stops tracking. This track panel contains various tools to manipulate markers already placed on the footage. The track option allows you to move the selected tracker 1 frame forward or backward, while the middle option tracks the selected tracker forward from the current frame. The clear buttons erase the tracked data from the selected tracker in either direction. The Refine option is not commonly used, but it refines selected markers by running the trackers from the track's reference to the current frame. Merge tracks is a frequently used feature that lets you combine different tracks into one tracker ID. For example, if a tracker is temporarily lost on the screen and then picked up by another tracker, you can join both trackers because they are tracking the same point in space, which improves the overall tracking accuracy. Now I will demonstrate how to add tracking markers, as well as how changing the pattern size and search size affects the markers. As you can see, I added a tracker on the screen by holding down the Control key and left-clicking the mouse. This allows you to add a new tracking point with the specified tracking settings. Hold Alt and press S to view the search size of the trackers. This area is where Blender will attempt to find the specified pattern during tracking. By clicking on the top left corner of the search area, you can change its location. If you drag the bottom right corner, you can adjust the size of the search area. By manually placing the trackers, you gain more control and can select points with high contrast, low motion blur, and non-moving surfaces like flags and leaves. This precise control leads to more accurate and reliable tracking in your footage. However, the major downside to this technique is that it takes a longer time to complete compared to automated tracking methods. Using the Detect Features button in Blender allows for automatic identification of tracking points with high contrast and low motion blur. However, it may not accurately recognize moving surfaces like a flag or areas with false changing perspectives. Manual placement is necessary in such cases to ensure precise and reliable tracking results. In the panel I just opened, you can see various settings for Blender's Detect Feature function. Placement determines where Blender is allowed to place trackers. Margin sets the proximity of automatically placed trackers to the edge of the screen. Threshold specifies the required contrast of the point compared to the background. Distance defines the minimum space between each tracker to prevent them from being too close to each other during placement. Once you are satisfied with the tracker's position and density, you can proceed to delete the tracks that are following a moving object, disrupting the perspective. After this step, you can start tracking the trackers forward from the middle frame of the timeline or a frame with a clear image to continue the motion tracking process. This approach ensures better accuracy and stability in the tracking results. For a good solve, aim for long-lasting trackers with stability. Here, I'm replacing this tracker to create a new pattern for tracking. In keyframe match mode, this is done multiple times. I recommend using the previous match mode, but that can instead lead to imprecision and sliding trackers. To obtain additional tracking data across other parts of the timeline, I use the Detect Feature function again at the start to acquire tracking data from that frame as well. This helps to increase the number of reliable trackers and enhances the overall accuracy of the motion tracking process. I continue to automatically place trackers using the Detect Features function throughout the entire footage to ensure there are plenty of trackers covering the entire movie clip. This extensive coverage of trackers improves the overall tracking accuracy and increases the chances of obtaining a successful solve. To check if the whole clip is covered, mute the footage by going to the top right corner, then hold Alt and press D to hide disabled trackers in the viewport. This way, you can better assess what the solve will see. If you notice frames with fewer trackers, repeat the process of placing more trackers as you did earlier to ensure comprehensive coverage throughout the entire clip. When there is a large amount of trackers, go to the Solve tab, where you'll find various settings. The first setting is the tripod setting, which tells Blender that your footage has only rotation along a point in space with no location change. The keyframe option enables Blender to automatically find 2 optimal points for a good perspective change, essential for the solver to understand how the space transforms along the footage. You can manually set 2 frames for the solver to understand from using the keyframe A and B options. Having around 20 to 40 frames between these points is recommended for an optimal solve. The next 4 settings allow Blender to automatically generate values it deems optimal for the scene. For instance, if you don't know the exact focal length or optical center, you can enable this setting to let Blender automatically come up with a value. I'll choose keyframe, focal length, optical center, and radial distortion for my first solve on the footage. Now I click Solve Camera Motion and wait for Blender's solver to calculate all parameters and return a solve error. Here you can see that I obtained a solve error of 14.7, which is an acceptable starting value. A solve error under 1 is considered decent, under 0.5 good, and under 0.3 excellent. Now we'll need to refine our trackers and use the cleanup functions to achieve a better solve error. With the cleanup function, you can filter by projection error and minimum tracked frames per tracker, which enhances tracking quality by removing poorly tracked points and achieving a more accurate camera motion solve. The graph you see on screen displays all the tracking information from our trackers. The green and red lines represent the speed of the tracker's vertical and horizontal movements, respectively. The blue line represents the solve error per frame. To minimize the solve error, remove green and red lines that do not follow the general curve. These curves represent trackers that have not been following the same movement as the rest, indicating inaccuracies and sliding around. Removing them will result in a more accurate and stable solve. You can also use the clear tracking options to remove tracking data from a tracker before and after a specific frame. After you have cleaned up the tracks, click on the Solve Camera Motion button again. Here you can see that I got an even higher solve error than earlier, but don't panic. This is a common occurrence in Blender's motion tracker. Now, you need to adjust the settings until you achieve a solve error under 2 pixels. I will try solving again to make Blender recalculate the solve. I still achieve a very high solve error. To fix this, go into the Clean Tracks option and remove more tracks using the projection error filter and set a minimum number of tracked frames. Now, I'll deselect the Automatic Keyframe option and adjust both sliders to another random value with the same difference between them. This allows for a different approach in solving the camera motion, potentially yielding better results. To further improve the solve error, I continuously change the keyframe A and B options, seeking a better motion tracking perspective. Between solves, I use the Clean Tracks option to remove trackers with the highest projection error. This iterative process helps refine the tracking and achieve a more accurate camera motion solve. After doing this process for a while, I achieved a solve error of 0.39. However, as I mentioned earlier, a track under 0.3 is considered excellent, so that will be our minimum goal. We'll continue refining the tracking settings until we reach our desired level of accuracy. If you get a higher solver error than earlier, use Ctrl-Z to reverse the latest changes, and then try adjusting the cleanup settings or the keyframes slightly. This allows you to fine-tune the tracking parameters and improve the solve accuracy. Remember, iteration and experimentation are essential in achieving the best results. Now I'll keep repeating this process for a while, and if I ever get the message that I have less than 8 trackers on every frame, I simply use the Detect Features function to add more trackers and continue. This iterative approach helps ensure a thorough and accurate tracking result. After you have achieved an excellent solve error, you can proceed to click on the Setup Tracking Scene button. This prepares the scene for compositing 3D objects into the footage. Next, I select 3 tracking markers to use as a floor in the 3D world and 1 tracker to serve as the origin point of the 3D world. Choose a point that is at the center of the action. These steps lay the foundation for integrating your 3D objects seamlessly into the footage. I also select 2 trackers to set the scale of the scene. Additionally, you can fine-tune the object scale further using the regular scale operation in Blender. This gives you precise control over the size and proportion of your 3D objects in relation to the footage. After you have completed all these steps, ensure that your camera tracking line is not shaky, as it indicates that Blender has not solved a stable and accurate camera tracking path. To ensure precise camera tracking, switch to the Layout tab and observe the corners of your 3D object to see if they match the ground's movement or if they slide around. If there is sliding, try creating a new floor with different 3D markers. You can also try moving the camera and adjust the tracker's ground to match the ground the objects stand on. Then, adjust the camera's rotation to match the perspective lines in your footage for better accuracy. You can also use the Set X and Set Y axis buttons to determine the direction the camera should be pointing in relation to the origin point. This allows you to adjust the camera's orientation for the best alignment with the scene. Congratulations, you have completed the entire tracking and solving part of the course. In the next section, we will explore how to import realistic assets using free add-ons to enhance your project even further. Stay excited and keep up the great work.